Great. I'm Dr. Anderson. This is the second in a two-part series for SAS. Today we're going to focus in SAS on data editing and cleaning. I do want to let you know that throughout this workshop, a notable amount of errors. This is intentional. I want you to be able to catch when there are things that are wrong. So at different points, the first SAS workshop was very much kind of you watch me, ask questions if you have them. And this workshop is a lot more interactive. And how we're going to do that. So I'll pose a question, or you may know something's wrong if you could put it in the chat. So I'm going to run through the background of research data services because we did at the beginning of each workshop, and I know that some of y'all didn't come to SAS 1, so it'll be helpful. If you could please go to this website that I have on the screen, it's going to contain all of the workshop information for today, and it's going to be important, especially for a handout that I put on that website. So I'm part of Research Data Services. Research Data Services is a group of faculty member and one graduate assistant that's housed within the library. All of us have different specializations, and you can see those here. We have a qualitative methodologist, we have a couple of data visualization people, and we have 3 people who focus more on quantitative methodology. The 2 quantitative methodologists are also here today in the workshop. So George and Jeremy, they both said hello in the chat. Jeremy's focus in quantitative methodology, he has background in data science, and he does coding in Python and in R. And then George is my graduate research assistant. He's a sociology graduate student here at Georgia State, and he focuses a lot on network analysis, but he codes heavily in R. He also knows some coding and teaches coding in SPSS and some Stata coding. So currently, I am the person in the library who uses SAS extensively. So if you have SAS questions, I'm going to be your kind of go-to person. If you're interested in general information about research data services, the website is right here. You can very easily search us in Google. If you just type in RDS GSU, so Research Data Services, Georgia State University, you'll be able to see what we have. This is the last workshop that is offered in the spring semester. We offered over 70 workshops this semester on tons of different topics. And if you're a Georgia State person and you have a question, you can email us for an individual or group consultation. So people keep asking us if we're still doing these, and absolutely, we're just doing them online. So after this workshop, I have a consultation with someone, and we're going to meet on WebEx, which is the same platform we're on right now. So we're also doing consultations that way as well. Certification, this is something that's really great that we do in research data services. And if you attend 5 different workshops in a semester, you get a data certificate. The data certificate is open to everyone, and it's at no cost. So we largely, overwhelmingly, the people who get this are Georgia State folks, but it's not limited by any means to Georgia State University. And how you get the certificate is you simply attend 5 different workshops and check in. So at the end of this workshop, I'll show the link of how to check in to this workshop, and you can attend other workshops to do the same thing. Something that's kind of a silver lining of us going online is we've recorded these workshops. So if you want to earn this data certification, you can still do that by watching other videos that have been posted online. So we have a website with the data certification that has information about the data certification, but it also contains all of the recordings. And that's the link that's put under this presentation will be recorded and uploaded to within the next few days. And there's a link right there. So if you want to get the data certification and you don't quite have 5, you can do that through that link. Briefly is the Graduate Research Intensive Program. GRIP is a program that I started. It was 2019 was its inaugural summer program. It's a 70-hour research intensive program over 2 weeks. This is open to only Georgia State graduate students. Last year we had about 250 applications and we accepted 20 people. The purpose of this is modeled after ICPSR, and we really focus on getting people strong research skills, and it's heavily quantitatively focused. So last summer we did all of our coding in Stata, and this summer we're going to do all the coding in R. The reason for this is that R is really one of the up and coming programs. Some people may argue it's already the predominant program. It's free and it's open source. So I want to make sure that people have extremely marketable skills when they graduate Georgia State. And this is my way of helping with that. GRIP is the only program at Georgia State that costs money through the library. It costs $40. The $40 covers your notebook, your jump drive, and then like snacks and stuff like that over the 2 weeks. Before we get into anything else, do y'all have any questions about research data services, our workshops, the data certification, GRIP, life in general, anything at all? Somebody asked prior to the workshop starting if we're going to do the workshops online this summer, and we are. We're going to offer them in a live format just like this, and we're also going to have recordings posted online so that people can watch the recordings if they have other things going on, or if they have limitations on being able to come to the live session. Someone just asked, due to the fact that the summer classes would be online, is GRIP online too? Currently, no. I'm trying very, very hard to keep GRIP in person, and because it's immediately preceding the fall semester, assuming, and I don't know, but assuming that we're back on campus at that point, we would be able to do GRIP in person. Personally, I think going to a 70-hour research training sounds kind of terrible online, but we'll kind of cross that bridge when we get there. My last resort is going to be canceling GRIP. The students who went through GRIP last year really liked it, and they got quite a bit out of it. So I'm hoping to keep GRIP, but hopefully in person. I think it works better in person than online. Are there any other questions that anybody has? How can we receive further information about the topics that will be covered in GRIP? Oh, great question. So if you go to the GRIP link that was posted in the chat, so George just posted a ton of links. If you go to the one that's near GRIP, it's research.library.gsu.edu/data-services/GRIP. That has a write-up of all the topics that we cover. Off the hip, we cover the research process, we cover type 1, type 2 errors, coding, analysis, all the way through logistic regression for statistics. So that's like all of the basic statistics. We also last year had a series of guest speakers that came in and talked about different things. So we also talked about like mixed methodology, social network analysis, null hypotheses, research hypotheses, model building, things like that. I will say that GRIP is last semester represented a ton of different departments. We had a social science group, a physical science group, an education group, kind of business law group, and health sciences. So we made a point to make sure that we had tons and tons of different types of students in the program. And I was able to recruit a social science expert and a physical health science expert so that they weren't, all of the examples weren't slanted towards my training, which is in sociology. So I made a point to make sure that we had tons of different people. If you're interested in GRIP, make sure that you apply. The applications are due at the end of June. People are notified if they're accepted in early July, and then the program is in early August. So it's a bit of ways off, but make sure that you get a complete quality application in. We can't know if you're a good applicant if you don't fill out the application all the way. So make sure you do that. Cool. If you have other questions that pop up in your mind throughout, just type them in the chat and we'll get to them when we break. So I'm gonna close this out or escape this, I guess. Go ahead and open up SAS here. So I want to open up the website that I asked y'all to go to. As you can see, I've already been on this website pulling stuff, but under the SAS 2 workshop materials tab, if you could please go and click on this handout and open it up for you. This handout is going to be important because we're going to reference it throughout the workshop. Let me zoom in a bit so you can see. We're going to have, last week we only had the variables that were originally in the data set, and this week we're going to have variables that are in the data set, variables that we create. So you'll notice that the part 1 is a code book. Can everybody read my screen okay? Is the font too small or is it readable? Let I know in the chat, can you read this font or is it too small? Okay, so it's good enough. Great. Thank y'all. So on the that there's the original variables in the data set, and on the right are going to be the different variables that we generate. So this should go ahead and clue you in that part of what we're doing today is generating new variables. So doing some data manipulation, some data editing. So you're going to need this as a reference. This is our code book for the workshop. You'll see that there's all of the code in part 2, and you'll even has the different colors so that you can really follow along, take notes if you like. Pass the code. Then we have our output. So this is everything that is produced today. I should really do this in LaTeX. It would look a lot better, I think. And then last for this section right here is part 4, opening data. I'm not going to spend any notable time on this section, but I do want to talk through it pretty quickly. So this is going to be a step-by-step with screenshot how to open data in SAS that's not SAS data necessarily. So the first section, it's just 2 little things of how to open SAS data. You go to File, Open Program, and then select the data or the code that you want to open. But then you'll notice that below that, it's import data not formatted as a SAS file. And I give you step-by-steps with screenshots of how to import data. I use Excel as the example, but you can follow these pretty closely for data that might be in Stata or R or any other SPSS, any other statistical package. But you'll notice that I've put in here tons of screenshots, circles, and arrows so that you know what and where. The reason I do this instead of doing it in the workshop and giving you the screenshots is because everybody's data are different. So you need to be able to run through this on your own. And you'll notice that it's not totally cumbersome, but there are some specific steps that you want to make sure you follow. So that's why I put screenshots in here. A data file that's a SAS file, it's really simple. You just go to File, Open. It's this little baby bit of code and steps right, well, not code, but these little bitty steps right here. And then if you want to import data that's not formatted as a SAS file, that's going to be the next kind of 3 or 4 pages of code here, or of output here. So I do specifically pick importing Excel data because every single statistical package can export a data file into an Excel. So absolute worst case scenario, you can use that to make it happen. Okay. Do y'all have any questions about this? Was everybody able to download this file? I promise that you'll want it for the workshop today. So was everybody able to get to the website and get this handout? Okay, good. If you weren't, that's fine. Just type it in the chat and let us know what your problems are and we can get you some help. So I'm just going to pull this over to my other screen. I know y'all can't see that, but I'm going to keep it open over here so that when I go to ask questions and when we go through things, I can tell you what page I'm on as a reference. Okay. Back to SAS. This is the SAS program. I downloaded this from the Georgia State University Software Download Center. Everyone who is a Georgia State affiliate, faculty, staff, and students can download SAS. So you'll just go in there and you'll enter your email or these are the same credentials for iCollege. You'll be able to do that. Just so I can have a general idea, can people type in if you're at a university, what university you're at, and then what program you're in or your area of study? If you're not at a university, if you could type in like just a title of what you do or what you're using your analysis for. If you're at a university, type in your university name and your department. And if you're not at a university, can you kind of talk about just briefly, like, what do you do? Okay, so I see we have a ton of Georgia State folk. We have some public health people, we have sociology, we have political science. Is anybody from any other departments or any other institutions? Okay, so we have a tech person, we have an engineering person. Cool. So to be frank, I'm a little bit surprised. Usually this workshop is almost exclusively public health folk and people who are demographers, because that's who the program was made for. Some economists, but generally it's public health people. So kudos to y'all for learning a language outside of your, kind of home discipline. Great. So what I want to do is I want to walk through the code just like before. Anything that we covered in SAS 1, I'm going to go a little bit faster on, and then anything that's new, I'm going to go a bit slower on. So as always, ask questions in the chat. There's not a ton of us, so I think that we'll be able to make sure we get everybody's questions answered. So just as a reminder, the editor window in SAS is where you're going to put your code. So the code goes into here, and then when it is run, it goes into our output window. So does anybody remember what is special about the star? So if a line of code starts with a star, what does that mean? So if a line of code starts with a star, it means it's a note. Some disciplines call these annotations. Basically, they're comments to researchers. Every time that you want to end the comment section, what do you use? When you want to end the comment section, what symbol or action do you use to end the comment section? Or note section, as y'all call it. Yeah, so you use a semicolon to end it, you use a star to begin it. And so once SAS hits a semicolon, it knows that that is the end of the code. This is a pretty universal standard in SAS. Whenever there is a semicolon, that means stop or run. So we see here that the end of the comments has a semicolon, and that tells SAS that this is the end of that. So this section is just a header saying this is how you pull in data. This is a header that I put in myself. The comments don't have to be in caps. I just put them in caps generally for my own, that's my own style, but they can be in any format that you want them in. So data SAS 2 is going to be how we define a new data frame. So by saying data, you're saying make a new database or a data frame, and we're going to call it SAS 2. The SAS 2 is just because this is the SAS 2 workshop. You could call it whatever you want. When I make databases, I have a tendency to name them after whatever the study was called. So if I use the General Social Survey, I may call it data GSS. If it was census data, I may call it census. So the name is not really important other than it needs to be one word. And I suggest you make it a short word because you'll be typing it over and over and over. So this first line of code says make a database, call it SAS 2. And then you'll notice that there's a semicolon, which means end, or that's the complete statement for this. The next line says input. And what do all of these things look like? What do you think age, child, iChild, HRS, EDUC, and EVCRAC are? They're variables, exactly. So these are going to be our different variable names. The variables need to be put in the order that you want the database generated. So this is when you manually input data into SAS. And remember at the beginning, I walked y'all through how to import data from other sources. But if you're manually inputting data into SAS, this is how you do it. You say input, and then you put the individual variable names in the order in which you want the database to be generated. At the end of that line of code, again, you have the semicolon. So you're telling SAS, input these variables in this order. And at the end of the variable names, you put a semicolon. The next section is going to be data lines. Data lines are going to be our individual datum points. So you say data lines and then a semicolon. And then you'll notice that these have a yellow highlight to them. So this first line are our first row of respondents. So this is respondent 1. This first value is that person's age. The second value is their number of children. The third value is their ideal number of children. The number 42 is how many hours they worked last week. 12 is their years of education. And 1 is have they ever used crack. So we can look at our original variable, and 1 means yes. So this person has used crack. And I pulled that from that handout I showed y'all at the very beginning, where EVCRAC 1 means yes and 2 means no. So this person has used crack before. Now, last week, we didn't see any data lines that have these decimals. Does anybody have a guess of what the decimal may mean for our data lines? So if there's a period or a decimal, somebody said it means NA. What does NA mean?
So if a variable is NA, it's missing data or no response. Exactly. This is really important in SAS. That the next value is an accurate value. So you see how these wrap, where we have this is respondent 1, this is respondent 2, this is respondent 3, so on and so forth. If I was to delete this 42, so I'm just going to pull it out, what SAS will do is it actually will not know that that variable is missing, and it will make this value where the 42 was. So the lines of data are actually just for the researcher to be able to see. Sometimes we can just run it all together. So technically, this is the exact same as what we had before because it runs through the different variable names, and then when it hits the last variable, it wraps. So these two ways of denoting the data are the same. So the reason that we have to put the period in is so that SAS knows that that datum point is missing. So some of you may call this NA, you may call a placeholder, no response, missing data, whatever. It just means we don't have a datum point for that person on that variable. So we'll scroll down and we see that we have all of these different data lines for respondents. At the end of the data lines, we have a semicolon. I hope that you're noticing and noting that a semicolon means that's the end of that section. And then we have a run statement. And then the run statement tells SAS, run everything that is a precursor to this up until the last run statement. So it groups things together. So here we're, just scroll back up, we're making a database, calling it SAS2. Then we're inputting the variable names in this order. Our data lines associated with those variable names are below. And then we have a run statement. So ultimately, we're making our database. So I'm going to highlight all of this. And then up here at the top, you'll see that there's a little running person. And when you hover over it, it says submit. So I'm going to hit the running person right here. And that forms our database. So I'm going to make this font bigger. Oops, sorry. Maybe I'm not. But this says that the data set SAS2 has 50 observations and 6 variables. So that tells us we have 50 respondents and 6 variables, which seems right. 1, 2, 3, 4, 5, 6 variables. And this looks like about 50 lines of data. So that tells us that that probably ran correctly. Immediately following that database generation, I have this explanation put in here. This is just like last week in the SAS workshop. Every time I introduce new data, I immediately follow, or new code, I immediately follow it with an explanation of that data code. So here it says data name. Now before this was above its data SAS2. Anywhere where there is a difference between the code that I ran and the explanation, that's what you replace it with. So where it says data name, you would replace that value SAS2 with your data name. And then input before, remember we had our different variable names here present. So then you would replace all of these with your variable names. And then you would follow it with your data lines and your run statement. So if we want to view our data, so we've generated our database and now we want to view it, we're going to run a proc print. So in SAS, print means show or view. So think of it as if you're electronically printing something, so you're making it appear. We're saying process a print on the data SAS2 and run. So I'm going to highlight this and run it. And let me make this, I think I can make this font bigger. So now we have what is very clearly a database or a data frame here. We have our number of observations down the left. We have our individual variables. And then we have the datum points for each person on each variable. So kind of looking at this, are there any themes that you see in our data? Is there a certain variable that has more missing? Are people really highly educated? Have most people used crack? Like what kind of things stick out to you looking at this data? I do want to tell you I made it up completely. So there's no like logic to the responses. So somebody mentioned that hours of work have the missing data. So I'm going to scroll through, and you'll notice that the only missing data is in hours that someone worked last week. So there's multiple reasons why this could occur. Why do you think we may not have the hours that somebody worked last week? What's a reason that that variable might have missing data while nothing else has missing data? So it's not that people dropped out of the study. It's not that, we have tons and tons of missing, but we do have people missing on how many hours they worked last week. So somebody said there might be a social desirability. So social desirability is when you tell the researcher what you think they want to hear so that you don't look bad. That potentially could be it. Is there another reason that we may not know how many hours someone worked last week? Why could it be missing? Any ideas? Yeah, so somebody might be temporarily working. If I ask you how many hours did you work last week, that assumes what? If I ask you how many hours did you work last week, what does that assume? That you worked, exactly. So if somebody doesn't work, then they can't have hours they worked last week. So I bring this up for you to actually look at the data beyond just the code. It's important whenever you open your data and look at it that you can note that things are logical. Now, if we were missing a ton of data points on education, I would think there might be something wrong with the database because especially if we assume that this is in the US, people are mandated to have education, but people are not mandated to work. So it would be maybe a little bit more alarming if we were missing education, but this assumes the hour variable assumes that you work and that you worked last week because it asks you how many hours did you work last week. So if somebody, kind of in the crisis that we're in right now, there's a lot of people who didn't work last week because they're not able to get to their job or their job was no longer exist or they didn't work formally to begin with. So that would explain why we have missing data here. Great. I'm going to go back to our editor. We have tons of editor windows open because I apparently opened a bunch of them. So I'm going to go to our editor and we have this code here. We're going to process a print on the data SAS2 and then run it. Does anybody remember from the first SAS workshop, if I just wanted to see the first 10 lines of data, what would I add to this code? Does anybody remember? So if I want to run just the first 10 lines of data, what would I add to this code? So we would set the number of observations here. So OBS 10 says I want to see the first 10 observations. So the reason that this may be a really good match for you is, let's say that you, a couple of y'all said that you're in public health at different institutions. Public health data often has tens of thousands, if not more, respondents in the database, and you may not want to look at all of the data. You may just want to look at a certain number of data points or response. So then you can set the OBS to a certain number. This is from SAS. This is not something that you remember. It may be because you missed SAS1, or it might be good to go back and look at the SAS1 information. So this is how you view the data in a table. Do y'all have any questions about how to generate a database in SAS or how to view the data in SAS? Do you have any questions about how to generate a database in SAS or how to view the data in SAS? So the next section that I want to do is run frequency tables. So frequency tables are going to be just these really basic tables that describe individual variables. So we're going to run a proc frequency. So a proc frequency stands for frequencies, generally tables. You say process a frequency on the data SAS2, and then run a table on the variable hours. So this is looking specifically at our variable hours and then run. So I'm going to highlight this and then run. And you'll see here that this gives us a frequency distribution. The frequency distribution on the far left are all the different response options that people picked. So people said that in the last week they worked between 4 hours and 99 hours. And then the next column is the frequency, which is how many times did people pick that response option. So we see that a lot of these are ones and they're pretty small. except for 40. 40 is rather large. There's 13 people who said that they worked 40 hours last week. Is there a reason why you think a large amount of people identified that they worked 40 hours last week? Remember, this is made up data, but do you have any theories of why that may exist at that level? Why people said that they worked 40 hours a week? So they may have a steady job, and 40 hours is considered full-time in the US. So if you work 40 hours a week, most people who work full-time work 40 hours a week. The following column is the percent, so that's the percent of people that chose that specific value. So 3% of people said that they worked 4 hours last week. 39% of people said they worked 40 hours last week. Following that, we have a cumulative frequency. Frequency is everyone on that row and all rows above it. So you'll see here it's 2. The cumulative frequency is 2, and that's because 2 people said 6 hours or less. So 1 plus 1 is 2. So here's our 2 here. Very similarly, the cumulative percent is the percent of people that are on that row and all rows above it. So there's 6% of people who said 6 hours or less, so 6 hours or 4 hours. You'll notice that 6.06 is the summation of 3.03 and 3.03. This is why it's important to make sure your variables are in a logical order so that the cumulative percent and the cumulative frequency make sense. And down here at the bottom, SAS will report if there is missing data points, that it tells you how many are missing. So we have 17 out of our 50 that are missing here. I'm going to go back to our editor, and I'm going to add in age. Let me add in child. So we can look at multiple variables at once if we'd like. We just simply put them in. The order in which you put the variables is the order in which the frequency distributions will be produced. I'm going to highlight this and run it. And you'll see that we still have the same output for hours. And then down here, we have child, and you'll notice at the bottom, there's no frequency missing. So SAS only reports that line if there is missing data. So if you have data points that are missing, it will produce down here a count of those. If you do not have missing data, it doesn't tell you anything. So if you don't see anything, that means you have complete data. So let me say that again. If you don't see anything down there, that means you have complete data. Go back to our editor window, and we have that explanation right there. So you see how it says proc, freak, data. So that all matches, so you wouldn't change any of that. And then it says SAS2 and data name. So to rewrite this code, you would replace SAS2 with your data name. And the second line says tables, and that matches. And then HRS versus var1. So you would replace that with variable 1. So that's how you run a frequency table. We talked about that last week, so that's why I'm moving through it relatively quickly. And then the other thing we talked about last week that I want to make sure we hit on again, because it's important that you know how to do these before you can generate variables, is running descriptive statistics. So process a mean on the data SAS2 in like old school statisticians refer to all descriptive statistics as means. So mean, median, mode are all measures of central tendency, and measures of central tendency are means. So this is saying process means on the data SAS2 and then run. So I'm going to highlight this. I'm going to run it. And you'll see that this gives us our descriptive statistics table or our summary statistics table. The first column is the variable names. You'll notice that they are in the order of the database. So they're in the order of the database. And then the next N, the N is the number of valid cases or non-missing cases. So you'll see everybody is 50. All the variables are 50 except for hours. And remember, on hours, we have 17 missing. We learned that in our frequency distribution. That's why this is 33. Following that, we have our mean. Our mean is our mathematical average. Our standard deviation is a measure of dispersion. So the bigger the standard deviation, the more variance within the variable that exists. And so what that means is the higher the standard deviation, the more range of variables that we see in the variable. Then we have our minimum, which is our lowest value anyone selected, and the maximum, which is the highest value anyone selected. So I explicitly say selected, not they could have picked. So if this is a study of adults, we see that the ages only range from 20 to 79. We know that adults in the US can be younger than 20 and they can be older than 79. So this doesn't report the values they could have selected, but it reports the values that they did select. The reason that I mention this is because in some statistical packages, the range that is reported is the range of values that people could have picked, but SAS reports the values that they did pick. So I think this is a strength of SAS, but I want to point it out. So if you're working in one program and a co-author or a colleague is working in another program, if your values don't seem to match, that could be why. SAS reports what people did pick. Do y'all have any questions about frequency distributions or summary statistics? Any questions about frequency distributions or summary statistics? If they, again, just put them in the chat. So this next section is new. So if you've kind of been I remember this from SAS 1, like come back, we're going to make new variables. So how we will do this is we're going to work through a series of different variables to generate, and then we're going to practice a little bit. So I'm going to give you different variables to make, and you're going to put the code in the chat. So the first one we're going to do is generating a variable that doesn't have any pre-existing data. Now, it's really important at this point that I tell you that in SAS, you can work with multiple databases at once. So you can have a database open called SAS2, you can have another one open called SAS3, and a third one open called SAS4. This is a strength of SAS. In Stata and in SPSS, you work with one database at a time. But SAS is more similar to R, that you can have multiple databases open at once. So what we're going to tell SAS is from the database SAS2, pull information. So there's a pull and then a place. This is saying from the database SAS2, pull, and then set our new variable into a database called SAS2. Now you'll notice that these both say SAS2 for this. That's because I want to pull from the same database that I'm putting this variable. But we could call this whatever we wanted, and we can make a new database out of it. But for the purposes of this workshop, I'm going to show y'all how to pull variables from a database and then place those variables back into that database. So pull from the database SAS2, then set this variable in the database called SAS2. The variable name is going to be called wave1, and make everyone equal to a 1, and then run. So this is how the code works. Now that you've heard it, let me tell you in placeholder conditions. Pull from the database called, set this variable in the database called, make a new variable that is equal to a specific value, and then run it. So I'm going to highlight this, and I'm going to run it. And I'm going to go to the results view. And the reason I'm doing this is I want you to see in the results viewer, nothing is produced when you make a new variable. Because we didn't tell SAS to produce results. We told SAS to make a variable. The reason I'm showing you this is I get a notable amount of emails from people that are panicked and they're like, Dr. Anderson, my code's not working. I keep making this variable and it's not showing up in the results. Well, remember, we didn't ask SAS to show us that variable. We asked SAS to make that variable. So if I go into the log, you can see that the variable was generated down at the bottom of the log. So I'm going to go to the editor here, and in the code, in the command box, or the chat box, in the chat box, I want you to tell me the code to run a frequency distribution on this variable. So just type the code in. Whenever somebody gets the code right, I'll paste it into the screen. So how do I run a frequency distribution on this variable? And remember, the handout has all of the code, so if you want to look at the handout as a reference. So run a proc freq. Remember, we have to have a data statement. So what is our database called? So edit that code and let's see what we get. So this isn't like a one-person show, so feel free to like throw other things in. So process a freak on the data called SAS2, right? And then what do I put here? So that's the first line of code. What's the next line of code? Again, remember that handout contains all of the code, so if you want to use it as a reference. So it's tables. So tables, wave 1, run. So process of frequency on the data SAS2, run a table on the variable wave 1, and then run it. So I can highlight this. In our output, we see that everybody is a 1 because we said make everyone equal to a 1. So there's not a whole lot to look at in this frequency distribution right here. So whenever you make a variable, you want to check and make sure that the variable was created accurately. I'm going to go back into my editor window here. And I like to have my code formatted like this. It doesn't have to be, but I find it easier to read. So if you want to make a variable that is equal to a constant, you just put the constant value in there. And then here's that code. So on the handout, that code was already in there for you. And then, so what a lot of people want to do is make a variable that is equal to an old variable. So they want to make a new variable so they can manipulate that variable. So how you copy an old variable is very similar to what we just did. From the database SAS2 pull, set this new variable into the database called SAS2. Make a variable called crackuse and make it equal to evcrack. So this is saying make a new variable called crackuse that is equal to the variable called evcrack and then run. You'll notice the only difference in between the old code and this code is we've replaced this with a variable name versus a value. So this is something that's pretty nice about SAS, is it has some universal arguments. So it goes pull from the database SAS2, set this variable in the database SAS2, make a new variable called crackuse and make it equal to the old variable evcrack, run. I'm going to highlight this and run it. And then if I'm copying an old variable, how would I run an analysis to see if the old variable is equal to the new variable? So what could I run to see if the old variable is equal to the new variable and that it was generated correctly? We can do a print and we could view the data in a huge table. We could definitely do that. We could say proc print data equals SAS2 and then run. So I can run this. You can say here's the crackuse variable, and then here's evcrack, and just kind of check to make sure they match. Another way we could do this is we could run frequency distributions on the original variable and the new variable, and that will let us see if they are the same. So we could say process a frequency on the data SAS2 and run tables on crackuse, and then we could also run it on evcrack and run. So you can compare these two to each other. I'm going to run this. This makes it really easy to see if the variable got copied correctly. So I spend kind of an ad nauseum amount of time in showing you how to check your variables to make sure that they're generated correctly. This is because so many people don't check their variables, and when they realize their variables were generated incorrectly is things like when they submit for publication, at their thesis or dissertation defense or something like that. So please do not go down the road of doing analysis and everything until you know that your variables are correct. So that's why I check things when I make them. I'm going to go back to our editor window, and those are how to just do basic copying, if you will. So this is how to copy an old variable, and then this is how to make a variable that's equal to a specific value. The next thing I want to show y'all how to do is more collapsing. This is generating a dummy variable. A dummy variable, sometimes people call them dichotomous variables or binary variables. These are variables that are equal to 0 and 1. So we're going to work through an exercise, and the thing that I want you to assume is that I'm a researcher who has come to you, and I want to know in my database who has children. So I want to have an identifier for people who have kids, and I currently have this variable called child. So I want to recode the variable child into a new variable where it identifies if people have a kid or don't have kids. And if they have a kid, make them a 1. And if they don't have kids, make them a 0. So this is a pretty common thing that people generate variables all the time. And it's a skill that you should have in every program that you code in. So this is saying pull from the database SAS2, set this variable in SAS2. So just like last time, every other variable we've made, pull from the database, set in this other database. We're going to make a variable called hasKid and make it equal to a period. So do y'all remember what the period, if somebody is a period, what does that mean in SAS? What does the period mean in SAS? It means that it's a missing data. So the reason that I usually make variables equal to missing and then recode from there is so that I accidentally don't remove people from missing into a valid response option. So we're going to say make a variable called hasKid and make it equal to missing. And then we're going to do if-then statements. So how if-then statements work is if, and then you say a condition, and if that condition is met, then the person is coded with a specific value. So if people on the old variable child said 0, which means they don't have kids, then code the new variable hasKid as 0. So ultimately what this line of code is doing is saying, if you're a 0 on the old variable, then you're a 0 on the new variable. So if the old variable child is equal to 0, then the new variable hasKid is equal to 0. So from here, we need to address our 1s. And so anybody who has a kid is going to be coded as a 1. And looking at our code book and that handout I asked y'all to download, you can tell that if somebody can have up to 8 kids. So if they have 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 children, then they have kids. And so we should code them as a 1. So if child is equal to 1, or if child is equal to a 2, or if child is equal to a 3, or child is equal to a 4, or child is equal to 5, or child is equal to 6, or child is equal to 7, or child is equal to 8, then hasKid is equal to 1. This is the first time that we've had code that wraps multiple lines. So if you notice, we actually have 3 lines of code that will run as a line of code, because remember that SAS runs until it hits the semicolon. So this code right here is the equivalent to this code right here. So you can have this on multiple lines. SAS is one of the only programs where you can split your code up and it won't cause any issues. So you can see that this is all one giant line of code that's not really easy to read or work with. So I like to do them in chunks. So we have this, and then we have our run statement. So I'm going to highlight this all and run it. And here's what comes up. So I want to thank you. In the chat, somebody says, is there syntax that we can use for more than or less than? Yes. So I have never taught this workshop either in person or online. I've never taught it in any format and somebody not asked this question. So you absolutely can. You can either split it up like this, or you can collapse it using greater than, less than, equal to signs. So we're going to do that in our very next variable. So good catch on that. You can absolutely do that. So I'm going to run our distribution on our new variable of hasKid. And so now we see that we have 50 people and 22 of them do not have kids, and 28 of them do have kids. So we made this by collapsing the variable child. So I'm going to go back into our editor window. And do y'all see how this is an or statement right here? They're all ors. This is saying that the person can be any of these values and be coded as a 1. You can also edit this and use different variables. So we might want to say if child is equal to 1 or iChild is equal to 1 and has kid is equal to 1. So you can use multiple variables in this. You can also change this or to an and that requires that each requirement is selected. So a respondent would have to say child is equal to 1 and their variable iChild would have to be equal. The or statement would be the respondent's child variable has to be a 1 or their iChild has to be 1. So I'm bringing this up because this is a really, really common question that I get from people when they're learning how to use SAS or making complicated variables. So remember, it is not and unless each requirement has to be met by each respondent. If they could meet the requirement by different standards, so by having child that's equal to 1 or iChild is equal to 1, it's an or statement. So this and or can be used in a myriad of combinations, but you want to be very careful about it. Okay, so that's the child one. Is there any questions before we move on to a different way of collapsing or binning? Is there any questions about this code? So the next variable we're going to do is going to use greater than or less than signs. So we're going to pull from the database SAS2, set our variable in the database SAS2. We're going to make a variable called full-time and make it equal to missing. And then we're going to say, if you work less than 40 hours, then full-time is equal to 0. So if somebody does not work full-time, there'll be a 0. And if somebody works full-time, which is 40 hours or more, then their full-time would be a 1. Y'all see this? Okay, so I want to ask you a couple questions just to make sure that this is really, really clear. If somebody is a professor and last week they worked 24 hours, are they full-time? On the full-time variable, would they be a 0 or a 1? So if somebody is a professor and they worked 24 hours last week, on the full-time variable, would they be a 0 or would they be a 1? Okay, so we have some zeros. Okay, let's say that you are someone who repairs dishwashers. So you're a wash repair person, and you worked 40 hours last week. Would you be a 0 or a 1? So the person who repairs dishwashers, would they be a 0 or a 1? Great. Okay, so the coding makes sense to us. All right, so I'm gonna run a proc freak. No, I'm gonna wait. So let's run this code right here. And that generates our new variable. And then variables like this, you definitely want to check. So I'm going to run a proc freak on full time. And then our old variable that we used, which was HRS. So we're going to run frequency distributions on both of these. So I'm going to highlight this and I'm going to run it. Proc freak data SAS2 tables full time. Did I not hit run? Well, this is fun. It's not showing up. Proc freak data SAS2. Did I run this first? This is fun. Variable full-time not found. Oh, that's because you have to spell the word right. So I misspelled full-time. That's why it didn't show up. Right. So here's our original variables for full-time. And we see here are the different hours that people worked. We have our frequencies here. And then here's our full-time variable that we made. So how can we see and check if this is right? How can we check if this variable is correct? How would we do that? Any ideas? How could we see if these categories that we generated for our new variable are correct? So we could look at the cumulative frequency, absolutely. So here we say people who are full-time 0, there's 26 of them. So what cumulative frequency would be 39 or less? So we look at this and we see that it's not the same number. So we have 9 people here, but that says 26. So there's 9 people here, and that says 26. What do you think might have happened? So I'm going to scroll so you can see the whole thing. So it says 9 people, but the value is actually 26. So somebody said it added the missing because they work 0. So what has happened here, and this is intentional, and I'm glad, good catch. Whenever you say less than, SAS assumes that missing is the lowest category. So you want to be very, very careful with your greater than or less than signs. If you use greater than or less than signs, if you say less than, it will code the missing as the lowest category. So I do this really intentionally. I want you to see this because most people just skip over it and they don't even recognize that it's an issue. But you notice up here in this full time, there is no missing data. All of the data are present. So what you'll want to do in this video is you'll actually want to add a line of code. So if HRS is equal to missing, then full-time should also be equal to missing. So what this does is it tells tells SAS, if you're on the old variable, we expect you to be missing on the new variable as well. The thing that is frustrating about SAS, and it happens all the time, you have to manually code the missing is missing. And so you may be saying, self, yes. Up here, I coded everyone as missing. So I should have addressed that. But remember that SAS considers missing to be the lowest category. So right here, when we said less than 40, then full-time is equal to 0, coded everyone less than 40, including the missing people. So there's 2 ways to address it. The first way is what I've put right here with the if hours is missing, then full-time is equal to missing. Does anybody have an idea of another way that I could have edited this code so that it only counts people who worked last week in the full-time variable? Are there any ideas? Kind of a complicated question, but are there any other ideas how I could have edited this code? Through the labels. So do you mean these here, or what do you mean by labels? Rename them. No, that wouldn't have done it because labels just overlay. But super complicated question. So that was kudos for guessing. How you do this is an and statement. Remember earlier I showed y'all you can put in here. So you can also say if HRS is less than 40 and HRS is greater than 0, then full-time is equal to 0. Now you could say, somebody may say that they worked 0 hours, so you may say less than or equal to. So these are pretty equivalent code. They actually generate the same output. I personally really prefer the missing statement because then I know that I'm directly addressing the missing, but both of these will produce the same output. So I'm gonna just run this so that we have the new variable there. And I can run a proc-freq on it again. And you now see that the frequency missing is 17. So good catch for noticing that it was there, and good attempts at fixing this directly. This is not an uncommon error. This happens quite a bit, and that's why I intentionally built it into the workshop as kind of a learning moment. Let's go back to editor. And now we've made these two variables. We can run a proc freq, which we already did to see that. You may be saying to yourself, I want to make a variable from multiple variables. So what we can do here is we can use multiple variables at a time to make conditional statements. So we're going to make a variable that measures the difference between how many kids you have and the ideal number of children that you say exist. So I'm really fascinated. I study family and I study disability. I'm always really interested in what people say that they want in a family versus what people have in a family. So we're going to look at the difference between how many kids someone has and how many kids they say. So before we generate this variable, I want to make sure that you know what the values mean. So if we take somebody's number of children and we subtract their ideal number of children, we're going to get a value, right? So if somebody's number of children is 5 and their ideal number of children is 4, then they're going to have a 1, which is a positive number. Y'all see this? Like, you just take how many they had and then take the difference. But if somebody had 4 kids and they said they wanted 5 kids, then they would have a -1, which means they have a negative number. And then if somebody has 5 kids, I don't know why I'm on this 5 kids. This is a lot of kids, but if you have 5 kids and you say you want 5 kids, then you will have a 0, which means you have 0 is you have the number of kids you want. So if somebody has a negative number, do they want more kids or do they think that they have more than their ideal number? So if they have a negative number, that means they want more children. If they have a positive number, does that mean that they want more or they say ideal number is less? Right, so it's less. So anybody with a positive number says their ideal number of children is less than the number of kids they have. Anybody who has a negative number says that they want more children, and anybody who's a 0 has the number of kids they want. So we're going to go ahead and make this variable, but I wanted to put this in here and I wanted us to kind of talk through this so that you know what the different numbers are. So we're going to pull from the data set SAS2. We're going to set this new variable in the database SAS2. We're going to make a variable called child diff. So this is the child difference score. And that's equal to the number of children that someone has and then subtract their ideal number of children and then run. So I'm going to run this. And then I'm going to run this proc freq so that we can see what they look like. So process a frequency on the data SAS2, make a table for the variable child diff, and run. I'm going to run this. We see people range from -8 to +5. So I'm going to go back to this really quick just so you can. If somebody has a positive number, they say that their ideal number of children is less than the number of kids that they have. If they have a negative number, that means they want more children. And if they have a 0, that means that they have the number of kids that they want. So looking at this, positive means you have more than the number of children that you think is ideal. Negative means that you want more children, and then 0 means you have the number of children that you think is ideal. So from this, we can kind of extrapolate different things. We see that the biggest category is -2, which means that the most common response that people have is they want 2 more children. I would go out on a limb, and I mean, this is something we could test, but I would assume that these are probably people who don't have kids, because there's kind of this American ideology of having 2 children. And then we see that there's 10 people who say 0, which means they have the number of kids that they want. And then not that many people say that they have more kids than they think is ideal. So of our 50, we have 3, 4, 5, 6. So a little over 10%, so 6 out of 50, say that they have more children than they would like. But 20% of people said they have the number of children they want. And then 68% of people say that they want more kids. So from here, I was to make a variable that identified if people want more children or if they don't want more children, what groups would I collapse together? So who would I collapse together for want more children? If I want to collapse together categories of want more children, which numbers would I collapse into a category here? So -8 all the way to 1, exactly. -8 to -1, -1 to -8, whatever. That would be telling us the people who want more kids. And then everybody else would be a 0. The reason I want to talk about this is when you're making a complex variable, sometimes you take multiple variables to do it. So if somebody wanted me to identify the people who want more children than they have, I would make a different score. And then from there, I would collapse that into a 0, 1 variable, where 1 is you want more children and 0 is you either have the ideal number of children that you want or you have more children than what you identify as your ideal. So I just want to talk you through that and get you to kind of get that mouse in the wheel running in your head to get you thinking about how you could take this a step beyond yet again. Okay, so I'm going to go back to our edit. Y'all have any questions about making a variable that's a different score? Subtracting variables from each other. This is why people who code have to be theorists and statisticians. Like the best coders I know understand theory and statistics because they can tie together the end goal product with the code and the statistics. So a lot of the best coders I know don't have their background in statistics or specifically coding. They're actually scientists from the physical, social, and health sciences because their research is theory based. So you want to think through what your end product needs to be and then make steps backwards to make those variables. Okay. So right here, I have code in here. I showed you how to do subtraction. To do addition, you just simply put an addition sign. Multiplication is the star, not an X, a star. And then division is the slash. I don't walk you through each of these because it's a pretty simple replacement function, but I want to point this out to you. And then if you want to, groupings, you use parentheses and all of that to make sure it's done effectively. So I just want to point this out. We're largely ignoring the annotations. They're notes for you later when you go through this workshop material. But these annotations are going to be really important, specifically so you can know how to do the different mathematical functions. So here's some different examples. If you have to do an addition and then generate a variable that's the multiplication, I suggest that you add them up first and then you multiply them second. This will allow you to check along the way. If you do multiple mathematical steps at one venture, it makes it much harder to check. So even as somebody who codes in a pretty advanced way and a notable amount of programs, I make these individual variables prior to rather than making a large variable with multiple steps. So if I need to add things and then divide them, I'll make 2 variables. I'll add them in one variable and then divide them in another. Okay. So ultimately, if you know how to, let me scroll up just a little bit. If you know how to bin variables or collapse variables like this, these are called conditional statements. So making those conditional statements. If you know how to use these operators effectively, and you know how to do these basic mathematical functions, you can do almost all data manipulation, variable generation. You just have to know the combination in which to do them in. So this is going to be really what I show you for generating variables. I strongly suggest, and I cannot suggest this enough, that you do them in individual steps rather than trying to do giant chunks at one time. So the next thing that I want to talk through is how to label variables. So labeling variables goes like this. In the database SAS2, set this into the database SAS2. So this first 2 lines of code are the same as when you're making a variable. Then you use the code label, and then you put the variable name, is equal to, and then in quotes, you put whatever you want the variable to be labeled. And you'll notice that it turns purple. So if I remove let me not remove that one. Let me remove the first one. If I don't have the quote, it's not in purple. So in SAS, if the code doesn't automatically populate, that usually means that you're missing some sort of punctuation. So I'm going to put the quote mark back in, and you'll it turns back to purple. So label the variable age as age in years, label the variable child, so on and so forth all the way through. We have these for our variables in the database. At the end of all the labels, you can put your semicolon and then a run statement. So open the database SAS2, set these variables into SAS2, and then label the variables. And you'll notice that there's no semicolon between these. There's no semicolon between these. So it's variable name equals, and then the quote marks, and then you just rinse and repeat that all the way through here. So I'm going to highlight all of this and run it. And then if you want to look at the data, somebody asked, if we want to keep all the variables on the same line, do we need to separate them with a comma? No, you don't need to separate them with anything. So this right here is the exact same as what I had before. So SAS runs through an iteration that says variable name equals quote, and then put in the variable name, and then you just repeat that over and over until you're done. Yeah. I like to just put them on separate lines because I think they're easier to read like that, but SAS doesn't need you to wrap cells for you. Wrap lines for you. So the prompt contents formula is saying process the contents on the data SAS2 and run. And this will give you a breakdown of all of the contents, each variable. So do y'all see this where it says there's a number and then the variable name, it tells you the type of variable, the length of the variable, and the label of the variable. Now, you'll notice that these variables are in alphabetical order. Then to the left of them, there's these numbers. The numbers are going to be the number that the column is in the database. So age is the first variable in the database, so it's 1, then child, then iChild, then hours, then education, then FCRAC, then now note, wave 1 is the first variable that we made. Remember, our original database only had 6 variables. So we made a variable called wave 1. Then we made a variable called crack use. Then we made a variable about has kid. We made a variable about full time. And lastly, child diff. So we have generated all of these. So this is the point where we're going to pause because this is a challenge to you. I'm going to leave this up on my screen. And I'm going to show you, I'm going to pull up the editor viewer just for a moment so that you can see how the code works. And you see how it says data SAS2, set SAS2, label, variable name equals, and then the quote marks. So I will tell you that this is wrong. There are multiple things that are wrong. An obvious one is there's nothing here for hours. So what I want you to do is we're going to take a couple of minutes and find the errors, and as you find them, identify them in the chat, and then once they're identified in the chat, send the code via the chat of how to fix it. So it's a two-step process. Identify the errors and then put it in the chat. And then once the errors have been identified, we'll put the code in the chat to edit it. So I'm going to pull this just over to the side. That's readable. Yeah, for sure. So I'm going to put that right here, and then I'm going to leave the code right here on this other side. So I want you to do is take these two windows and what's wrong over here, and then tell me how to fix the code. And remember that handout I asked y'all to, let me pull this up. I asked y'all to look at. This has the code book, so it will tell you what everything should be, what each value should be equal to, and what the variable should be called. So open up this and take a few minutes, and this is troubleshooting. So whenever I teach, like when I teach statistics, I always get my students to troubleshoot and figure out what's wrong with it. So I'm going to pull this over and make sure you have this handout handy. And then you chat what errors are, and then how do I fix it with the code? Two separate messages. So I'm gonna just kind of sit here and talk aimlessly so you don't think that the WebEx crashed. But look at what I have on my screen and then identify what's wrong. So can anybody pick out something that's wrong in our results viewer, in this table of our variables and attributes? Oh, okay. So one person said respondent has used crack is equal to 1. So if you look at the code book, that's correct. So if the respondent has used crack, they should actually be a 1, not a 2. So how do I fix that code? Type the code into the chat box of what do I need to change in my code? And then does anybody else notice any problems or errors in our results viewer? So what else is wrong over here or missing over here? Is there anything missing or wrong? The answer is yes, but what is it? Help me out because the chat's quiet. Is it that you don't understand the question or you don't see what's wrong? Can you let me know? You don't understand what you're doing or you don't see anything wrong? I'm going to copy over this new line of code. So there's something about crack use. So we have the ev crack. Is there something wrong with crack use as well? Somebody said the crack use in the chat. Is there something wrong with the crack use variable? So we're looking to see in this output window to being what's wrong with it. So the value of 2 is you have not used crack. No, you're actually right. There is something wrong with it for this crack use right here. So when we make errors, we're usually really consistent. Remember that ev crack and crack use are copies of each other. Did y'all see how this one says respondent has used crack as a 1, and then here respondent has used crack is a 2. So this one says it's a 2, and this one says it's a 1. So which one is correct? If a respondent has used crack, are they a 1 or are they a 2? So if a respondent has used crack, would they be a 1 or would they be a 2? They're a 1, exactly. So I'm going to copy over this because they should match. There's one other really big error. Does anybody see the other really big error looking at this? Like what's missing over here? Maybe like in this area right here. Y'all see how there's nothing for hours? So we would need to add in the hours information. So I'm just going to type in HRS. Yeah, exactly. You're exactly right. We're missing hours. For HRS, we're going to type in number of hours worked last week. And then that will edit it. So I'm going to run this code. Those are the errors. The respondent has used crack was wrong in both places. And then we didn't have anything for hours. So those were the three things that we edited. So I'm going to run this code. And then I'm going to run the proc contents again. Now notice that this is the proc contents now. I'm going to rerun the proc contents. And when I rerun it, it updates what we changed. So number of hours worked last week was changed. The respondent has used crack and the respondent has used crack. So good catches. Those were the 3 big errors. And then the next thing that I want to do is not just label the variable names, but label the variable values. So I want to show you what they look like currently. Do you see how this is a 1 and a 2, and then a 0 and a 1 and a 0 and a 1? So most of us have used data that looks something like this, and we just look right here and says respondent has used crack is equal to a 1, respondent has child is equal to a 1, and respondent works full-time is equal to a 1. But if we're going to share our research with other people, specifically if we're going to share our research with people who are not statisticians, we want to make sure that these are really labeled well, because the average person off the street will get confused by this. So we need to actually label, like, what is a 1, what is a 2. So I want to show y'all how to label the variable values. So how you do this is you do a proc format statement. Now, this is the first time that we don't have a data statement. So I want you to note that. This is the first time we don't have a data statement in the 2 hours of workshop we did before and the hour and about half of this workshop. We have not had any code that didn't have a data statement. The reason we don't have a data statement here is we're just formatting. So the labels are like stickers, or they overlay onto the variable. They actually don't have anything to do with the data. So we're going to process a format. Then I want to make a value, and a value is going to be the label name. I want to make a value of crack use LAB. So crack use label. This is my kind of naming protocol in SAS. You could call it whatever you want. I like to call it the variable name and then LAB, so I know it's the label. Where 1 is no and 2 is yes. And then it's going to generate that value. And then we're going to generate a value for has kid. So has kid LAB, where 0 is no and 1 is yes. And then I'm going to make another value, that's the end of that value. I'm going to make another value that's full-time LAB, so full-time label, where 0 is no and 1 is yes. We have our semicolon and we run it. Do y'all have any questions about this? So this is generating the label. Do you have any concerns about this? Does anything seem off or wrong about this code? So any questions about it, or do you think these labels are right? So in the chat, will you type yes if you think these labels are correct, and no if you think these labels are wrong? So yes if the labels are correct, and no if they're wrong. Worst case, you're wrong, and that's fine. So if you think they're right, say yes. If you think they're wrong, say no. So somebody said no. Somebody else says, doesn't it need to be consistent with 1 and 2? They are not correct. There is one that is wrong. So somebody, great. Somebody says crack use value 2 is no, right? And 1 is yes. Exactly. So in this crack use label, I intentionally did it wrong the whole way through. I did it wrong when we labeled it, and I did it wrong when I made the variable values. And the reason I did this is because we usually are consistently wrong. We commit to an error and we do it over and over and over. So here, this 1 should not be no, it should be yes. And this 2 should not be yes, it should be no. So this is really important that you don't kind of mindlessly make these, you check them over and over. One person says, does it need to be consistent for 1 and 2? What it needs to be is you need to address the specific values of that variable. So if you look at that handout and in the first section of the code book, you'll see that there's the different numbers there. Some of these variables are coded as a 0, 1, and then some of these variables are coded as a 1, 2. So I personally almost exclusively use 0, 1 variables because that's how I was trained and that's the most effective for me. But a lot of databases that we get are labeled 1, 2. So whatever they're originally labeled as is how you would want to make sure you make the labels. So that was the error in this code. So I'm going to highlight this and run it. Now we have made the labels, but we have not adhered the labels. So this is important. It's a 2-step process. Step 1 is the proc format where you make the labels. And then step 2 is where you adhere the labels. So the next thing that we need to do is we need to add those labels onto the variable. So this is how you do that. Process of frequency on the data SAS2. Format crack use and add the crack use label, and then there's a period. So this is saying format, variable name, label name. Now it's going to be really clear to you why I think you should make the label, whatever the variable name is, an LAB. It makes it super easy to identify what label is for that variable. So format, crack use LAB, period. So you have to have the period. And then you can repeat this for other variables. Has kid, LAB, period. Full-time, LAB, period, and then semicolon. And then I have tables, crack use, has kid, full-time. So this is how you adhere the labels. You use this format statement. I want you just for a moment to ignore what I have highlighted and look at the rest of this code. What is that code for? We've done this code tons and tons of times. Remember, proc freak data tables. What does that produce? Proc freak data tables. What does that produce for us? We've seen this code before. What does a proc freak do? Yeah, it makes a frequency table. So what I do is I nest my application of labels with a frequency table so that I can adhere the labels and then look and see if the labels worked. So this is actually code nested in other code. So this is code nested in other code. So I'm going to highlight this and run it. And now you'll see that these have the labels on them. So yes, no. And this is readable by basically anyone. Anybody could pick up this table and see, okay, if they know that crack use is about using crack, you know that yes is 1 and no is 49. So 98% of people have not used crack in my made up database, and 1% or 2% have used crack. So this makes your data very readable. If you have never collected data before and you've only ever databases, this is probably what you're used to receiving. So you're used to getting like clean data that's fully labeled, but no, somebody on the back end had to do all of that. The data does not come labeled. You have to manually do this. So I have spent tons and tons of time when I was a graduate student just labeling variables and generating variables for mentors and studies that I'm on. So this is a good skill to have. Y'all have any questions about how to make the labels with this proc format, or how to adhere the labels with this? So a question came in that says, if I want to recode crack use lab as 1 is yes, 0 is no, what should I use? So just so you know, if you do 1s and 0s, the label won't work on the variable because the variable is 1s and 2s. So if I change crack use lab to 1 is yes and 0 is no, this label would not work because 2s are no's. So I'm going to just rerun this and then rerun this down here. And you see how this 2 without a label. So if you want to make the variable a 1, 0, then you would have to generate the variable. So you could generate the variable and say, let me just kind of put it this right here. So you would say, this is just from earlier in the code. You would say dataset SAS2 set SAS2 make a variable crack use is equal to 0. And then let's call it crack use 1. And if crack use is equal to a 1, then crack use 1 is equal to a 1. And if crack use is equal to a 2, delete this, then crack use 1 is equal to a 0. You would actually need to make a new variable like this and then adhere the label. Does that make sense? Yeah, cool. That's a good question. That's something that people do all the time. So I'm sure that's why you asked. Like, this is a very common practice of having them 0, 1. And then earlier somebody said, don't they need to be consistent with 0, 1 or 1, 2? So y'all are both hitting the nail right on the head with that. Absolutely. Okay, so let me go back down here. And so that's how you label your variables. Y'all have any other questions about how to make a label or how to apply a label? Cool. So let's do a practice question. Let's do this. So I'm gonna make let me take this variable right here. I'm gonna scroll down, just kind of ignore the heavy amount of scrolling that's going on right now on my screen. I'm gonna make a new variable and I'm gonna say, I'm gonna look at people who work less than 40 hours and they work more than, say, 10 hours. And we're going to call these people part-time low. Or let's call work. Let's just call it work. So I'm going to make a new variable that's work, and it's going to have 3 levels. So the first level is going to be people who work more than 0 hours, but they work less than or equal to 10 hours, there'll be a 0. And then if they work less than 40 hours, but more than 10 hours, there'll be a 1. And then if they work 40 hours or more, then there'll be a 2. So I'm making a whole new variable. I'm going to do this so that you can make the label for it. So I'm going to highlight this and run it. What I want you to do is I want you to make a label where 0 is part-time less than 10 hours, where 1 is part-time more than 10 hours, and 2 is full-time. So I want you to make a label for this variable. So let's put it in the chat. I've made the variable for you. You see that the variable's name is work. So we're going to make a label for the variable work. So take a couple of minutes and grapple with this a little bit. I'm going to make this bigger so that you can see the steps. So I want you to make the label, and once we have the label correctly made, then we'll apply the label. So here's the label formula or label code. So it might be easier if I copy this up. Sorry. So use this code right here and manipulate it to edit for what this requirement is down here. And I'm going to paste it into the chat so that you have it. So how do I make a label for the variable work? Let's see who can get it in the chat. So label work, hours worked. Okay, so that's how we label the variable. How do we label the values? So how do I make this for this right down here? I'm just going to kind of chill and see what is produced. So what you're doing right now is producing variable label for that. So we have a valuable work where 0 is work 10 hours or less. Okay, and then how would I do 1 and 2? I'm just going to kind of put in here what y'all have as it comes up. other lines of code that people have produced? We're using this right here, this proc format, to generate a new label for this right here. Okay, so then we have one part-time. Okay, cool. So I'm going to take this one and copy it. Now remember, we don't have to repeat value work over and over. Okay, so that's our one. What about our two? Oh, cool, cool, cool. So we have a two. So two is full time. Now remember that this cannot be the variable name. So what should I call this? Because the variable name is work, but we need to make a label for the variable work. What would we call that label? Work LAB. There's multiple things missing on this code still. Yeah. So we value the label name 0, 1, and 2. So we're missing a couple of things on the top and bottom end. So what are we missing on this code? It's not a star. So we're missing the semicolon. So there's a semicolon here. What else are we missing? We're missing two big things. Anybody see what they are? We don't need the equal sign. We actually do need the equal sign, but they're in the wrong place. So the equal sign should not be there. The equal sign should be here. So 0 equals, 1 equals, 2 equals. And then we're missing our proc format. Now y'all see how I'm pointing as if you're looking at my screen. Y'all see how this is not colored. This is just black. It's because we don't have this proc format statement. So as soon as I add this, you'll notice that it changes. Y'all see how it changes into the proc. From here, we're missing something else. What else are we missing? So look at this code right here. And then look at our code, and we're missing one big thing. What are we missing? It's not walking, but missing something from this code right here. We're missing our run statement, exactly. So we're going to type in our run statement, and this tells SAS that this is a complete code. So we're saying process a format, make a value called work LAB, where 0 is part-time, 1 is part-time, part-time less than 10 hours, part-time more than 10 hours, 2 is full-time. I put the semicolon here. You could also put the semicolon on the next line. It doesn't matter. And then we have our run statement. So we can make this right here. Now, taking that we have the label, how do I adhere the label to the variable? So currently, I already made this, but let's run it. So if I run as it currently stands, I run a proc freq data SAS2 tables work run. That's to run a frequency distribution. And y'all will see that it's 0, 1, and 2. So 0, 1, and 2. How do I adhere the label? What would the code be to adhere the label? Let's try to get that in the chat. How would I adhere this label? Well, I can copy the code. I think that might make it easier on your own computer. So here's the code for when we added all those labels in. So how would we alter this code to add our new label in? Ideas. So what we're doing is we're editing that code to adhere our new label that we've made. Very slowly start typing it to see if it shows up in the chat. So Prop3 data SAS2 format, we're missing one thing on this. That's correct, but we're missing one thing. What are we missing? One. Perfect, perfect, perfect. So process of frequency on the data SAS2 format, work with work LAB. So adhere, work label onto work, and then run. Now we see our variable that we have generated is produced right here. So this is nice, you know, like on the fly in the span of, I think it took 6 minutes, we made a new variable, generated a label for that variable, and adhered that label. So this is something that you should absolutely develop if you're going to be serious about data manipulation and data editing to be able to do this. So that's how you add the labels in. The last thing that I want to show y'all is how to export all of your output into Word. So how we do this is we do an ODS RTF. So ODS stands for Output Delivery System, and RTF stands for Rich Text File. So what we're telling data, telling it to do is say, use an output delivery system for a rich text file. Then call the file sas2.rtf. So all I'm doing is I'm saying, generate a file called SAS2, and it needs to be an RTF because we're telling it to make an RTF. So output delivery system, rich text file, name the file SAS2.rtf. You could call it whatever you wanted, but it needs to be a .rtf and then end. That's that statement, right? And then we put in whatever we want to be generated in the output delivery system file, and then we close it out. So this is how it works. You open an ODS file, you run whatever you want in the ODS file, and then you close the ODS file. And when you do this, this automatically makes a Word document. So I'm going to run this, and then touch your computer for a second. And it opened in a different window for me, but I'm going to pull it over so y'all can see, or open it on a different screen. And do y'all see how this is just a Word document? This is in my Microsoft Word. My name's right up here, so this just opened up in Word for me. And what it does is it timestamps it and date stamps it for you, and paginates or paginates it for you. I actually don't know how to say that word correctly now that I've said it out loud on a recording. And then this is going to be the output that you asked for. So we asked for the output of the different variables. So that's what's here. And you'll notice that whenever there needs to be a page break so that it fits, they're all in here. So you may be saying to yourself, but I want a bunch of stuff. You know, like I want a bunch of different things in my output. How do I run and save it somewhere onto my computer? So instead of just making a Word document, I want it to save a document somewhere for me. And I'm going to show you how to do that. So how you do this is you say, make an ODS, so output delivery system, rich text file, and then call the file path of where you want it. And then you name it, and then it ends in RTF again. So you say, I want an output delivery system, rich text file, make the file and place it here. And then again, you put whatever you want in that rich text file, and then you say that you want it to close. So this is going to be contingent on the computer that you have. So I'm just gonna, like, you could just open up your file and then say you want it saved to, I'm gonna make it in documents. We're gonna save it in logistic regression. It doesn't matter. You'll just replace that path name right here. And then you'll put a backslash, and then you'll put whatever you want the file to be called. So I just called the file 1, and I could call it SAS2. And this will place this file in that location on my computer. So this is really nice. If you have a folder that you want to save all of your homework or your output to, you can just go ahead and nest it in there for yourself. So I'll highlight this and run it. it outputs it, and you'll see that it automatically opens it for me. So I just wanted if the respondent works full time in my output delivery system. And so that's all this document is, because that's all I asked for. So here in your rich text file, you can run everything if you want. So what I'm going to do is I'm going to comment this out. Y'all see how it goes green? And I'm also going to comment out this statement right here. And I'm going to copy this line of code. I'm going to actually put it at the very top. What it will do is it will make this entire, all the code that I've run into a single output. SAS 2A, because this is a different document. I'm going to hit Control A, and I'm going to run this. I'm going to give it a minute, and you can see it's thinking hard. And then I'll pull this over again so y'all can see it. It's made this document, and down here I know that the font's probably too small to see, but it's a 22-page document, and it has all of our output from today. Now, I just want to remind you, I mentioned this in SAS 1, that anytime you have a run statement, it does a page break. So each of these are on different pages because there's a page break in between. Now, SAS will overrun on to the next page and make natural breaks. It does not split tables, but every time you have a run statement, that's a new page. So I'm going to zoom out. I know that you won't be able to read it when I zoom out, but I want you to see what it looks like as far as it's formatted. You'll see how these have different pages and there's huge gaps below it. And then some pages, like this one right here, is a pretty full page. So whenever you run a series of statements together, it does a page break at each run statement. So if you need things to be on their own pages, you would put in tons and tons of run statements. But if you want them to maybe like this page or this page, the ones that have a heavy amount of text on them, then you would use a run statement more sparsely. But if you are using analysis that run multiple pages, so this is an example of that. This right here is just looking at the database, and you'll see how it actually goes into 2 pages. So this is line 35, observation 35, and this is observation 36. SAS naturally breaks tables for you, and it labels them pretty nicely. So that's a nice thing about SAS. The other thing that I personally really disliked when I was a grad student, but I really like it now that I'm a faculty member, is you see this timestamp right here. So I know when this output was generated. Now, this always isn't great for those of us who have to meet deadlines because it tells you if it was generated at the right time. But I find myself using this quite a bit with output. If I'm like, I know that I ran this output last Wednesday, then I can look at the timestamp and know what day it was from. A lot of people copy and paste output from SAS. Please don't do that. This code is very, very simple, the ODS RTF, and then that way you can output your code. The really important thing is that you make what I call an ODS sandwich. You do the ODS, so it's like your bread, and then the meat is the analysis that you want, and by meat, whatever you put in your sandwich, and then your ODS close. So you start with an open statement. That's where you identify the name of the file. Then you run whatever you want in it, and then you run your close statement. And this makes kind of that ODS sandwich that I was talking about, and it generates the output for you. Otherwise, you're going to be stuck manually copying and pasting the results, and that's just not a good use of your time. So I want to make sure that since this is the last of the series that I showed y'all how to output your files. Y'all have any questions about outputting files in SAS? About how to do it or anything like that? Just as a reminder, you can use an RTF or a rich text file in a PDF reader, so like Adobe or something, so you don't have to open this in Word. The default is it will open in Word, but if you have a rich text file, you could open it in a PDF viewer or Microsoft Word. I don't know if you can open it in like Google, whatever they call Google Word, but you can open it in any other. Okay, so since there's no ODS questions, are there any SAS questions that you have in general? Because this is, the last of the series, so I want to make sure if anybody has questions that weren't answered, you have a moment to ask them. Okay. If something comes up, just say it. It's fine. So if you would please, everyone, if you could check in. George has very graciously put this information, but you want to use this to check in. As a reminder, for the data certificate, you had to have watched or attended 5 workshops by April 20th at 8 a.m. And if you're in a different time zone, we're in Eastern, but it's April 20th by 8 a.m. And how we know that you have watched it is you check in here, and the link to check in for the workshops is in the chat. And then I just pasted it by itself so that if you're kind of getting lost amongst all the links. I will stick around and answer any questions that you have. Right now, I'm going to turn off the recording. And remember that the recording will be uploaded to the website that's been posted in the chat. Okay? So I'm going to turn off the recording, but I will stick around to answer any questions you may have.